Algebra 2, 6-6, rational, oops, I wrote roots, rational exponents. Goodness. Rational exponents. Sorry about that. Okay, rational exponents is what we're looking at. So rational, whenever we see rational in math, usually it means we're going to be talking about fractions. So b to the 1/2 equals the square root of b. b to the 1/3 equals the third root of b. Here's an example. 4 to the 1/2 power is the square root of 4, which is 2. 27 to the 1/3 power is the third root of 27, which equals 3. So what we've just done here is I've shown you that the denominator goes here, the numerator goes here. And we'll do some examples. You'll see more what we're talking about here. -16 to the raised to the power of 1/2. That gets me the square root of -16. Now, we're not supposed to take the square root of a negative number, but we're going to say the square root of 16 is 4, and the square root of -1 is I. We're not really going to look at I, but that's what's happening there. So we can just ignore for now if you've got a negative number inside the radical sign. Just say no solution. We're not going to be talking about I yet, but I just want you to see it. Okay, let's move forward. Let's do some examples. I've got d raised to the power of 7/4. So we're going to rewrite this as the denominator becomes the index number, and the numerator is the power next to the number. Now, if I'm going to continue to try to simplify this, this is d to the 4th times d to the 3rd. So I can take this d to the 4th out. The 4th root of d to the 4th is d, and I'm left with d to the 3rd inside. So I've got d times the 4th root of d to the 3rd. Another example. A to the power of 2/3. So the denominator is the index number. The numerator is the power inside the radical there. Now, this power can be outside as well, but this is the way we're going to do it for right now. A squared, I can't do anything with it to the 3rd power, so this is the answer right there. There's nothing I can do to it. Let's do another example. C to the -5/3. Now, this negative in the exponent, hopefully you can remember, what that does is say, I'm unhappy here, put me on the other side of the fraction bar. And so this really is 1/c to the 5/3. And if I'm going to rewrite this, I've got 1/, the 3 is the index number, and c to the 5th here. Now we should keep working on this and rationalize the denominator. I didn't do that when we did the notes last time, but let's do it anyways. So this is c to the 3rd times c to the 2nd. So I need another c down here, cubed root of c. So I'm going to multiply the top and the bottom both by the cube root of c. So c times c to the 5th is going to be c to the 6th. So I've got the cube root of c over the cube root of c to the 6th, which is the cube root of c over 6 divided by 3 is c squared. And that should be my final answer. Okay, let's have you try. Let's have you try a couple different ones. Here's you try 81 to the negative 1/4 and negative 3125 to the negative 1/5. Yeah, try those two. Get your calculator out for this one, right? And see how you do. All right, go. All right, so this one here, I'm going to first rewrite it as 1 over 4. And then, so the 4 goes here for the index number, and the 1 just goes with the 81 like that to the 1. Okay, notice how it's not negative 1 over or 1 over negative, this negative just says put it on the other side of the fraction, just like that. So the 4th root of 81 is 3, right? 3 times 3 times 3 times 3 times 3, so that's 9 times 9. So yeah, so the 4th root of 81 is 3. So I have 1 over 3. That's my answer. Now this one is ugly, right? 3125. Hopefully you figured this out. So first I'm going to rewrite this. So this is negative, so I have to put this whole thing, over. And this is so I'm taking care of the negative, so I've put it down. This is going to be in the denominator here. Now this 5 is going to be my index number, the 5th root of negative. So this negative is the negative that I'm going to keep. But I am actually going to keep it not inside here because that's not mathematically correct. The negative is out in front, which means that it's not in parentheses here. So that's not getting the power, the 1/5 with it. This is out here on its own. This all happens here by itself, and then the negative gets attributed to it later. So I'm going to put the negative on the outside. And then I have 3125. 3,125 is it 9? 1, 2, 3, 4, 5. Nope. One, 2, 3, 4, 5. Oh, it's 5. Okay. So the 5th root of 3125 is 5. So this is 5 to the 5th power. So the 5th root of 30,125 is 5. Negative 1/5 is your answer. Phew. Okay, let's do a couple more examples here. 216 raised to the power of 2/3. Okay, so I'm going to rewrite this with 3 as my index number, and then 216 squared. Okay, so now there's a way that I can break this 216 up without having to multiply by itself. 216 is 6 to the 3rd power. 6 times 6 is 36. 36 times 6 is 216. So watch this. Cube root of 6 to the 3rd squared. So see how these two are equivalent terms? Now I can go 2 times 3 is 6. Or I can say, so there's another way to say this. I can say this is 6 cubed times 6 cubed, right? 6 cubed squared is 6 cubed times 6 cubed. And when I multiply, then I add the exponents. So I get 6 to the 6th power. Cube root of 6 to the 6th power. Or I can say 6 cubed times 6 cubed, cube root of 6 cubed, and the cube root of 6 cubed ends up being 6 times 6, which is 36. Or I can say 6 divided by 3 is 2, and so I end up with 6 squared, which is 36. Watch that again if it doesn't make any sense. Okay. Here, let me show you another way to do this one. I've got 216 to the to the 2/3. Now I can rewrite this as, I already know 216 is 6 cubed. 6 cubed is 216, and 216 to the 2/3 power. Now look at this right here. And when I raise an exponent, I can multiply these instead of add them. Like I add here, but I multiply here when I raise it to the power. So I've got 3 over 1 times 2 over 3. And so these 3's cancel out, and I end up with 2. So this becomes 6 squared, which is 36. So that's another way to look at it. Let's see, let's do one more way to look at it. Look at this. There's all these different ways to do this. 216 to the power of 2/3. You can also look at it this way. The cube root of 216, and all of this is squared. So this time I took this numerator and I put it on the outside. That's okay to do. I can do that if I want to. I can put it inside here, or I can put it outside there. It's up to me. I get to do whatever I want. Well, not really whatever I want, but I can make that choice. Whichever one is going to be easier for me. And so you can see 216 is 6 cubed. So I've got the cube root of 6 cubed squared. The cube root of 6 cubed is 6. 6 squared is 36. Whew, look at all those. That's fun, isn't it? A couple more examples to go, and we'll be through having all of this fun. Hopefully it's not too dark. Not too dark? All right. Simplify. All right, example. A to the 2/7 power times a to the 4/7 power equals 2/7 plus 4/7 is 6/7, a to the 6/7 power. Here's another example. B to the negative 5/6 equals 1 over b to the 5/6. So I just took this negative, flipped it down here like that. Now, this says 5/6 here. I want to rationalize my denominator. And so I'm going to multiply. I want this to be 6 over 6. So I'm going to multiply by b to the 1/6 over b to the 1/6. And so when I add these two, I end up with 6 over 6. So that becomes 1 times b to the 1/6 is b to the 1/6 over b to the 6 over 6 is just b to the 1, so it's just b. So I've rationalized my denominator by adding these fractions together. You try one. 27 to the 1/4 over 3 1/2. All right, so I want you to rationalize the denominator and then simplify it out the rest of the way. Rationalize the denominator first, and then go through the rest of what you think you can do here. All right, so This is a good question here. So go ahead and pause and see what you can do here. All right, welcome back. Let's see. Hopefully you went like this. You followed this example here that we just did, and I want this to be 3 to the 2 over 2, and so I need to multiply by 3 to the 1/2. So that way I'm going to have 3 to the 2 over 2, which is 3 to the 1, and so that's just 3, right? So I'm going to multiply both of these like that. Now I end up with 27 1/4 times 3 1/2 over 3. All right. Now I can't cancel out these 3's. This is the square root of 3, right? And this is the 4th root of 27. So I can't really do anything to these yet. I gotta keep going. So what I'm going to do here is I am going to try to get. I need a common denominator, and I need a common base. So this is the base, and I want a common base and a common denominator up here. And so what I'm going to do is I'm going to change this to 2/4. Okay, so 1/2 and 2/4 are the same. Now, here I gave you a U-try that has some really tricky stuff in here. 27 is 3 to the 3rd power. Okay, so I've got 3 to the 3rd power, which is 27, to the 1/4, times 3 to the 2/4, over 3. Whew. Now, I'm almost ready for these bases to be the same. See, now 3 times 1/4 is how I simplify this here. So 3 times 1/4 is 3 to the 3/4 power times 3 to the 2/4 power over 3. Now that I have the same base and the same common denominator, I can just multiply these together, and when I do that, I add the exponents. So I have 3 plus 2 is 5, so 3 to the 5/4 over 3. Okay, now I've got 3. Now I'm not quite done yet because I can still, there's still something more I can do here. And I can go like this, 3 to the 5/4, not 3 and 5/4, I can draw it bigger, 3 to the 5/4. Remember the quotient property, when I'm dividing, I subtract the exponents. So this is 3 and 5/4, 3 to the power of 5/4, divided by 3 to the power of 4 over 4. So divided by 3 to the power of 4 over 4. So 3 to the 1 is the same as 3 to the 4 over 4. So when I do that, I subtract the exponents. So I end up with 3 to the 1/4. And that is my answer, 3 to the 1/4 power. Ooh, ugly but good. Okay. You might need to look through that a couple more times before it makes sense to you. But that is 6-6. Good luck on the homework.